Okay, so I'm going to be doing the worksheet for Carnot cycle and ease. Just before we do that, just to note that there's 3 different ways to type comments in ease. The first way, you could do it in quotations. Second way, you can use squiggly brackets. And third way, you can do just 2 backslashes. And then if you want a comment, first I'll show if you hit calculate solve. These comments are blue. If you want the color to be red, a quick way to do that is to put an exclamation point before you type any words. Just do comment 2 again. Calculate solve. Then you can see that that one comes out in red. So now we'll start. Do quotations. Do Carnot cycle. Just gonna put it in red. Then before I type any of the values in, I just like to write down all the states just to organize, that you'll see later. State 2, state 3, state 4. Okay, now if we look at the problem statement, constant temperatures in the boiling condenser are 200 degrees Celsius and 20 degrees Celsius. So we see the boiler, state 2 and state 3 are 200 degrees Celsius. So we'll type that in here. Do T2 equals 200 degrees Celsius. And then we'll do temperature at state 3 equals the temperature at state 2. Then we know condenser, so state 1 and state 4, 20 degrees Celsius. So we'll do T1 equals 20 degrees Celsius and T4 equals T1. Says also the mass flow rate is 2 kilograms per second. We're going to use that to solve the energy values in the end. So I'll just make a separate comment, energy values. Here I'll put m dot equals 2. And then again, if you want to specify units, you do square brackets. And also, if you want to specify the element number in an array, you do it in square brackets too. So this is array T, and that's element 4 in array T. This would be element 1 in array T. So now that we have all of our givens, we just have basic knowledge now of how the Carnot cycle functions. We know saturated liquid and saturated vapor at inlet and exit boiler. So at state 2, it's a saturated liquid. It has a quality of 0. So we'll do x2 equals 0, and then we just put a comment that it's a sat liquid. Then we know state 3, x3 equals 1. This is a saturated vapor. And now we see at state 2 and state 3, we have 2 thermophysical properties. And you know from thermodynamics, if you have 2 thermophysical properties, you can find the rest of them. So we're going to go to options, function info. You want to go to thermophysical properties. This is a real fluid because we're using steam. You can't use the ideal gas assumption for steam. You want to find the working fluid on the right side, steam. Then you want to find that the value you're trying to compute. We can also, instead of doing them all individually, you do real thermoprops. You can find all the values you want with just the 2 we have. And again, state 2, we know the temperature and the quality. So independent properties, we have temperature. Here we need to change this to quality. We hit paste. We have call. So we want T to equal this T2. And also ease does not recognize capital and lowercase letters. So even though here the array X is capital and here I'm going to put it as lowercase, it's not going to make a difference in ease. I'm going to put 2. And then this colon separates the input variables, which is the working fluid, the two independent properties, and then the output variables. And we want this to be labeled as T2. You can also just delete that T2 part since we already know it. It's kind of redundant, but it doesn't really matter. That's how we find all of the properties at state 2. And then we can do the same thing at state 3. So we do options, function info, thermophysical properties, real fluids, steam, real thermal props, and again, temperature and quality. Oops. Okay, paste. And then this is state 3, so we just want to make sure it's equal to state 3. Okay. Now we need to find the values at state 1 and state 4. We can look back at our diagram on the worksheet. See that 3 to 4 is through isentropic turbine because it's the Carnot cycle. So we will write, and again, we know the entropy at state 3 because we just found it using this real thermal props procedure. We have it here. So I'm going to do S4 equals S3. And then we can again do the call real thermal props, options, function info, thermophysical properties, real fluid, steam, real thermal props. This time we have temperature and entropy. Specific entropy, do paste. State 4, so we just have to specify for our array table. Okay. Then we have state 1 left. You see state 1 to state 2 is pump, and since Carnot cycle, it's isentropic process, so we know S2 equals S1, and we found S2 here. So we could put S1 equals S2. Then we have two independent properties, defined all the rest of them. So we go options, function info, thermophysical properties, real fluids, steam, real thermal props. We have temperature, specific entropy, paste. Then just make sure you have the correct specification of the array. Okay. Now we have all of our thermophysical properties at every state. We're going to compute the power output of the turbine, heat supplied to the boiler, heat wasted by condenser, required power pump, and thermal efficiency of the power plant. So we'll put that under our energy value section. So we can do work dot T, so that's power of turbine, equals m dot times H3 minus H4, and then we can denote the units if we want. Watts, I believe it's watts. W dot P, so now we're doing, well first we'll do B, so that was A, we could do B now. So heat supplied to the boiler, Q dot B, so this is the heat into the system, M dot times H3 minus H2. Then we got to find heat wasted by condenser, so Q dot C equals M dot times H4 minus H1, then required pump power, W dot P equals M dot times H2 minus H1. We have all our energy values. Now we need to find thermal efficiency of power plant. So we do eta equals W dot T minus W dot P divided by the heat into the system times 100. Here we have all the values we need. Okay, so now that we're finding everything, I'm just going to maximize this screen before I run. So I'll do calculate, solve, see if there's any errors, illegal variable name, blah blah blah. I'm going to remove the units and see if this makes a difference. Okay. So here we have our array table. Drag this down. You see we have all the states that we found. And here are all of our arrays. We have all of our values. Here we have thermal efficiency, mass flow rate, heat into the system, heat out of the system, pump power, turbine power. Now if we want to make a TS and PV diagram, I'm just going to go out of these. We can go to plots. We could do new plot window. She might help. Put this at the bottom. Plots, new plot window. Nope. Property plot instead. Hit property plot. Remember, we're doing real fluid because this is steam. Then you want to find steam. Let's do a TS diagram first. Something that I would find helpful. You can just exit out of these lines if you don't want them. I'll show you what you'll see what they mean soon. I'll just put all the pressure points down. 2.339, 1.555, and again they're these values here. I'm just rewriting only those. So we're only including these. Include specific volume. So I'll do 14.04. Oops, 04. Then we have 0.001157, 0.1272, and 42.33. Gonna uncheck these boxes. You can change the line color. We're gonna keep them. And again, we found the specific values here from our array table. Gonna hit OK. So those lines I just created are the pressure lines in the TS diagram and the specific volume lines that we see here. Now we need to overlay this plot that we created with our array points. So we'll do overlay plot, TS steam. So we want our x-axis to be the S array. We want our t-axis to be the T array. And again, we only have one table here, but the array table, the main, we could choose the color. I'm going to choose red, symbol, do triangle, line, just do a dash line. Oh, I forgot why. Why we want T, y-axis, so hit OK. It's loading. Let's try this again. We want S, T, okay, I don't know why it didn't work the first time, but here you see it. But you see this is state 1 to state 2, state 2 to state 3, state 3 to state 4, but there's no line from state 4 to state 1. So we have to go back into our equations window and create an imaginary state 5. And we're just going to have all the arrays in state 5 equals state 1, just so that line connects. So we're going to have, we can do all of them, but it's only a TS diagram, so we're just going to do T5 equals T1. Oops. S5 equals S1. Got to solve this again. And here you can have a better view of the array table. Also, if I drag all the way down, we only specified a 5th element in the T array and the S array. So you see there's no state 5 in these arrays because we never specified one. Then go back to the plots. We have to overlay another plot over the one we just made. So we have S, we have T. We can make this one purple, it just came out. Okay, and now you see we have purple. And you see it did not get rid of the green, so we have purple over the green, but it doesn't really matter because it's the same thing. I can also hit this zoom button, zoom in on this point. Now we have this, we have TS zoom, and zoom in again, I think. I don't know, just so you see the green underneath, so it didn't get rid of that previous overlay plot we created, it just went over it. I'll go back to the original. If you want to delete, you could just right-click, delete, right-click, delete, or you can right-click and save. I'm going to save. Do documents, do ease mentor, do my script, do Carnot TS Steam, save, open up a Word document, just so if you have to write a report or if you just have a quiz you have to submit. See. Insert, oh goodness. Ease mentor. Okay, yeah. So then, if you have a report or just need to submit a quiz or something, you have your TS plot, and you can do the same exact thing with a PV diagram. I won't go through the whole process, but again, you do plots, you would do a property plot, and we pick TS. Instead, you would pick PV, and you just do the same thing over again. That is the Carnot cycle in ease.